So hello everyone, and today we will be seeing one of the problem from Geeks for Geeks. The problem is pretty simple. It says transform to some tree. Now we are given a root of a binary tree with n nodes, where each node may contain a positive or negative value. Convert it into a tree such that each node's new value is equal to sum of all the value in its left and right subtrees based on the original tree. So new value is this, and for the leaf node update their values to 0. Cool. Now they want us that new value should be equal to sum of all values. Let's see one example and we can understand how we can solve this one. This is a tree and we have to check. So 10 is converted into 20. How? Because 10 is 4 minus 2 plus 12 plus 6, and 4 12 came out from 8 and minus 4. 8 minus 4 is 4, yeah. 7 and 5 is 12 it is. So 4 12 and minus 2 and 6, it gives you 20. Nice, makes sense. So it is simple as that. It is not very complicated. Only there are few certain things which we can mess upon is where does the original value reside. So if we are having a minus 2, we are not using minus 2 for itself, but I am using children for myself, and I am being used by my parent. So minus 2 is being used by 10 but not itself. So 8 is being used to create a new value over here. So that is what I mean. As the definition also says the similar thing. Not similar, same thing. Value in its left and right subtree. Okay. So what I mean is a new value is equal to left subtree sum plus right subtree sum. So we have left subtree sum, we have right subtree sum, and we get the new value. Obviously if we are storing this new value within the node's data, but the original node data value would be gone. So let's take a backup of it. Why I'm taking a backup of it? Because I am not using node data here directly, but my parent needs this. So in this case here of 6, the value of 6 is not used for creating a value 12. For creating a value 12, only 7 and 5 is used. So where does the value 6 used? 6 is used to create 20. So you see, 6 is used here along with the 12 which was created, and that is it, my friend. Ultimately we need to return the backup plus the left sum plus right sum. So I'm just using shorthand. Left sum means left subtree sum, the right sum means right subtree sum. So whatever solution comes up, we need to return that. That is what we have done earlier as well. So left sum plus right sum plus my current value gives you a parent, at least half of a parent from left, and from right it will give you its own. Cool. I guess there's not much thing over here to do. Let's implement this within the code and let's see where does it goes, and are we getting any test cases missed or not. So what I'm doing here is I need to check whether, first of all, if root is null or not. If it is null, then I'll just return 0. Easy, plain simple. Now what I'm saying here is new value, calculate new value. So how do I calculate new value? Left subtree sum plus right subtree sum. This is the way. right, or else write sum plus left sum. So I'll say new value, int new value is equal to left sum. How do I get left sum, by the way? Well, I'll get left sum by, I'll have left sum to some tree, because this tree will itself give me left sum tree, root dot left. And why it is giving me left sum tree, I'll tell you once again that hey, below this, below 8, where is nulls give me 0, and that is where at 8 I came up with 0. At point 10 I came up with the sum of all of this, but not 10. So at each point, if I wanted to get the sum, I'll just call the method and I'll get the sum. Likewise for right also, I'll do the same. Right. So new value is nothing but left plus right. Cool. Instead of that, I'll just, again, I'm storing this new value into node.data, so I'll not use any new variable. I'll just store this within node.data. But mind that if I'm storing it the node.data value, where does the original value reside? It would be gone. So I would just store a copy of it. So I'll name it as data node.data, or a better name can be current data. That's it. I'm storing my children's with me, and I wanted to pass myself to my parent. So what I'll do here is current data plus node.data. This node.data contains left and right, and that's why n plus me. So don't need to worry. Instead of node.data, I can just go ahead and write this one. So my left, my right, and myself, I am giving it to my parent. And obviously this is void, I need to convert it to int because I'm returning this one. And yeah, I think this would run. We are doing the same thing, backup plus left sum right sum, same thing, backup plus left sum right sum, and I don't think there is nothing much left. Let's compile this one. Let's see whether I'm okay. Cannot find a symbol. Current data node. Okay, node they cannot find because node is not a value. It is root, not node, root. Cool, it passed for sample test case. Let me try to submit this one. And yes, it is passed for rest of all 110 test cases as well. So this was about it. It was a pretty simple depth first approach. It was asked in these many companies, and expected time complexities of n, auxiliaries of height, and again which we respected. And yeah, this was a pretty simple question from trees. If you wanted to know more about trees, data structure, click the video on your right, and I will see you in the next one.